In this video, we're going to learn how to solve radical equations. And radical equations are, of course, just equations that contain radicals in them. So here are the steps. I'm going to read them for you guys. So step 1, we're going to isolate the radical using addition subtraction. Okay, so that means you want to get it by itself. Step 2, we're going to square both sides and simplify. Step 3, if the equation still contains a radical, go back to step 1. So the reason it says this is because sometimes when you square both sides, you get rid of one radical but not another in case it has more than one. So that means you're going to go back to step 1 and start over. Otherwise, we're going to go to step 4. At this point, all your radicals are gone. You're going to just solve the equation. If it's linear, remember, it has one answer, and if it's quadratic, it has two answers. You might end up with either kind. Finally, the last step, check your solutions in the original equation. Now, you might think that it's optional to check your solutions, but actually you must check your solution anytime that you square an equation. Let me give you a brief sort of example of why you have to do that. If we look at this equation and we ask ourselves, how many solutions does it have? This has one solution. Right? One solution. Now what happens if I square both sides? If I square both sides of my equation, I get x squared equals 4. Notice that this actually has two solutions. What are they? They're 2 and negative 2, right? But what's important about that is that I got this equation by just squaring both sides of the original equation. So this is proof that squaring both sides of an equation may lead to answers that are not really answers. So we must check all of our solutions in the original equation. We must do this. Okay, this is not something that you can skip. If you're feeling lazy, you have to do this. Okay, so let's do a couple of examples. We're going to solve the following. Z plus 9 minus 1 equals 0. So square root of z plus 9 minus 1 equals 0. We're going to go step by step. So step 1, isolate the radical using addition and subtraction. So the first thing I'm going to do to isolate the radical is add 1 to both sides. I end up with square root of z plus 9 equals 1. Now, step 2, square both sides and simplify. So I'm going to square the left side and square the right side. On the left, if you square a radical, it just goes away. You get z plus 9. And on the right, 1 squared is just 1. Nothing to simplify, so I go to the next step. Notice there are no more radicals, so I go to step 4. Solve the equation. It's a linear, so it's going to have just one solution. I get z equals negative 8. However, I have to check my answer. So to check it, I plug it into the original equation. So is this true? Well, let's see. Negative 8 plus 9 is 1. Square root of 1 is 1. We end up with 0. So it does indeed work. So therefore, z equals negative 8 is our answer, and we box the answer. Okay, do not box the answer till after you've checked it. Alright, let's try another one. So problem 2, we're going to solve the following. It'll be a similar example. Square root of 5 plus 8 plus 7 equals 5. So step 1, isolate the radical. We're going to subtract 7 from both sides. We end up with square root of 5p plus 8 equals negative 2. Now we're going to square both sides. We end up with 5p plus 8 equals 4. And now we solve. Again, we have a linear, so I'm going to just solve and get one solution here. I get 5p equals negative 4. Divide by 5. You get p equals negative 4/5. Don't forget that we have to check our solution. Sorry about that. Let's check it right here. So I'm replacing the p. 5 times negative 4/5 gives us negative 4 plus 8, which gives us 4, which gives us 2, which gives us 9, which is not equal to 5. So this does not check. Therefore, this is not a solution, and in fact, we have no solution. Right? Since the only solution we found didn't work, it must have no solution at all. Okay, let's get a little bit more tricky. Square root of 2k plus 11 plus 2 equals k. Now, this one doesn't look all that much harder at the beginning, but let's see what happens. The first step is to isolate the radical, so I subtract 2. I end up with square root of 2k plus 11 equals k minus 2. Now here we're going to square both sides, but be careful. You cannot square the right by just writing this. That would be wrong. You have to actually multiply it out using FOIL. First, on the left we have 2k plus 11. On the right we have k minus 2 times k minus 2. We get k squared minus 2k minus 2k plus 4, or k squared minus 4k plus 4. Okay, so now we have a quadratic. We got to get everything to one side. So I'm going to subtract 2k, I'm going to subtract 11, I get k squared minus 8k minus 7 equals 0. Again, a quadratic equation, so remember how we solve this. We have to factor. So I can factor this by writing, let's see here. Now hold on, did I make a mistake here? Yes, I see my mistake. It shouldn't be a minus 8k, it should be minus 6, because negative 4 and negative 2 make negative 6. There we go. That's better. Now this thing factors. Negative 7 and positive 1. Right? Those multiply to negative 7 add to negative 6. Okay, so now we set each factor equal to 0. On this one, we get k equals 7. And on this one, we get k equals negative 1. But we have to check both of these answers. So first we're going to check k equals 7. I'm going to plug in 7 into the equation up there. So is this true? On the left we get 14 plus 11, which is 25 plus 2, which is 5 plus 2, which is 7, and that's equal to 7, so it works. Now let's try k equals negative 1. 2 times negative 1 plus 11 plus 2, is that equal to negative 1? We end up with negative 2 plus 11, or 9, plus 2, or 3 plus 2, which is 5, which is not negative 1. So actually, this answer doesn't work. The only one that works is this answer, so we box it. You can see now why it's so important to check our work. It actually happens quite often that the answer that we find doesn't work. Okay, let's try another one. We're going to solve the equation. This time we're going to have two radicals in our problem. 5y plus 4 equals, and then y plus 8. Does this increase the difficulty? Well, let's just see. Step 1 says to isolate a radical. Notice that they're both already isolated, so I can go right to step 2. Step 2 is to square both sides, so I'm going to square the left. I'm going to square the right. I end up with 5y plus 4 equals y plus 8. Notice this is a linear equation, so I'm going to move everything, I'm going to move the variables to the left and the numbers to the right. I'm left with 4y equals 4. Divide both sides by 4. I get y equals 1. Don't forget, I have to check my answer. So I'm going to put in y equals 1 into my equation. First I have 5 times 1 plus 4. On the right I get 1 plus 8. This becomes 5 plus 4, which is square root of 9, which is 3. On the right I have square root of 9, which is also 3. So it works. So y equals 1 is my solution. Alright, one more example. This is going to be a tough one. A lot of you guys are probably thinking, wait a minute, I never did have to go back to step 1, right? What is this business about isolating a radical and then isolating it again? Well, here's going to be our difficult example. Square root of v plus 7 minus square root of 2v plus 7 equals 1. Okay, so we're going to start by isolating a radical. Now, which one? We have two radicals here, and neither one is isolated, so we have to do something. So I'm going to isolate the left one. I'm going to do that by adding square root of 2v plus 7 to both sides. Now be careful, on the right those are not like terms, so I still have to leave them separated. So this is what I get. Now I'm going to square both sides. Now be really careful because on the left I'm just squaring a radical, so I get v plus 7. On the right, when you square this, you have to be really careful because what you're doing, again, is you're going to use FOIL because there's two terms, right? The 1 and the radical. First we multiply the 1's together, we get 1. Then we get square root of 2v plus 7 times 1 is square root of 2v plus 7. Then we're going to multiply these two, we get square root of 2v plus 7. Finally, the last one, the two radicals multiplied together, the radical cancels, we're left with 2v plus 7. We have to simplify our answer, so on the right side, notice first I have a 1 and a 7, so that gives me 8. Then I have the radical 2v plus 7 and the same radical again, so I get 2 radical 2v plus 7. And then I have plus 2v. Where do we go from here? Well, notice the step 3 said if there's still a radical, go back to step 1. So now I have to start all over again. But notice I only have one radical instead of 2 at the beginning, so I'm already in better shape. So I'm going to start by moving everything that doesn't have a radical over to the other side. I end up with 2 square root of 2v plus 7, and on the left I have negative v minus 8. Sorry, negative v minus 1. Now what? Well, I've kind of isolated the radical. I could divide by 2 right now, but I'm going to leave it alone because now I'm just going to square both sides. Now, what do I get over here? Remember, I have to use FOIL. So negative v minus 1 times negative v minus 1. I end up with v squared plus v plus v plus 1, or v squared plus 2v plus 1. On the right, if I square the 2, I get 4, and if I square the rest, I get 2v plus 7 without the radical. Distribute that, and I get 8v plus 28. Notice this is all a quadratic, so I'm going to get everything to the left side. I end up with v squared minus 6v minus 27 equals 0. I'm finally ready to solve the equation since all the radicals are gone. So I factor this. I want two numbers that multiply to negative 27 and add to negative 6. Notice those are negative 9 and positive 3. So in fact this becomes v minus 9, v plus 3 equals 0. Set each factor equal to 0. I get v equals 9 and v equals negative 3. Now remember, we have to check both of these. So first I'm going to check v equals 9. I get square root of 9 plus 7 minus square root of 2 times 9 plus 7. Is that equal to 1? Well, let's see. We have 16 here. 18 plus 7 is 25. We get 4 minus 5, which is negative 1, which is not equal to 1. So v equals 9 is not a solution here. Let's try to check the other one. This time we're going to check v equals negative 3. On the left side, I get negative 3 plus 7 minus, and then I get 2 times negative 3 plus 7. Is that equal to 1? Hopefully this time it'll work. We get square root of 4 minus square root of negative 6 plus 7 is 1, which becomes 2 minus 1, which is indeed 1. So this answer does work. So the idea is every time you have an extra radical, you're going to have to square it that many times. That's basically the bottom line. Always make sure you check your answers and always remember the process. Thanks very much for watching, and I hope you guys watch some more. Thank you.